It's hard to check. You gotta get a college there.
Let's see. So their original problem was what? This? Okay, we do first outer and last. What are you doing this right here? So you get right. Okay, 4x times 2 is 8x
Alright, guys, this is it. Ready?
outer. 4x times x is 4x squared. We don't have
Everyone, look up here. Remember?
Then we do inner. What's 3 times 2? Okay. What's 3 times 2?
Better. We're getting somewhere.
Plus
If you're
6,
not done,
and then we do last. What's
that's
3
okay.
times x?
Okay, if you're not done, that's okay. I know some of you did finish.
X squared and this
And I
is
want to talk about those of you who
this
finished.
is an x.
Raise your hand if you found a mistake in the one that you were receiving. Raise your hand if you found a mistake. You guys finding all these mistakes?
Okay, what's
Hope they were intentional. Alright, who would like to share something that they found? Mark, what did you find?
Well, we already did this. Well, the equation was this. 3x plus 3x. Okay. 3x minus 3x plus minus 5.
3x what?
Minus 5. Parentheses. Again. 8x minus 7.
Alright. So what do you have to do to solve this, you guys?
Well, first step was to. Well, the first step was to add 3. Well, instead of multiplying, they added. So this person was.
So what was the next line they had at work?
What's the next step? What do they do? Minus 5x plus 3x. They got minus 5x plus 3x minus 10 minus 12.
How do you think they got that?
They added instead of multiplying. It was a negative 3x. What was this? In the top.
Oh, okay. So you guys, when we do FOIL, remember we're distributing, we want to multiply all the terms together. Negative 3x and 8x, if you add them, would be negative 5x. What would it be if you did it correctly and you multiplied them? What should that be? Negative 3x times 8x. Raise your hand if you know what that should be. Yeah, right there. Negative 24x. What do you guys think? Thumbs up, thumbs down. Negative 24x, which is negative 3x times 8x. I need a confirmation from one of you guys. Yeah? What happens when you multiply x times x? X squared, remember? If you have something squared, what that means is you're multiplying it by itself. If we have x times x, you did the numbers correctly. Negative 3 times 8 is negative 24. But then we have x times x, which is x squared. Something to watch out for. Alright, so the mistake here was that they added instead of multiplying. I like it. Who else has one they want to share?
Hugh has one.
I have one. Is it really complicated? Okay, Quinn, what do you have? Hold on, does it have to relate with the distributive property or is it just crazy numbers? Okay, let's not do the crazy number ones though. I like these two. 1 second, guys. Priya, which one did you have?
Okay, 9. Okay, so they did 4 plus 9. And then 5 divided by 5.
Like this?
Yeah. And then
Okay.
they just did 14 times 1 equals
14 times 1 equals 1?
1.
Okay. Interesting. Was there a mistake made with the distributive property? They said that this is 14, and then this is 1, and then they multiply it. Is that okay? Is that legal? You could do that. Say that equals 1. I don't know about that. I would say 14 times 1 equals 14. Okay. Nice. Who else has one that's a really good example of a mistake that would be made with the distributive property? I think you have one. Alright, we're taking DKs. Last one.
No.
Again, we're going to have to do FOIL for this one. Alright. DKs then says on the next line, what do you think? Here's your hand if you see the mistake. Got one hand. Got 2 hands. You got 3 hands. Raise your hand if you see the mistake.
Oh,
Right?
it says be x squared, not 2x.
Already gave it to us. So yeah, x times x. We have an x, and we multiply it by itself. What is that? X squared, right? If we were adding them, we'd have two of them, but we're multiplying them. So this should be x squared. Awesome. So you guys, it's kind of easy sometimes to make mistakes with the distributive property when you're using a lot of x's and a lot of numbers.
Unless it was on purpose.
Unless it was on purpose. So I want you guys to keep that straight. All right, nice job. Let's look back at our sheets we had. All right, here we got a nice little story about some swimming pools. We're moving on today, and instead of doing swimming pools that are in the shape of squares, look at these wild swimming pools in different shapes. All right. Sure.
I'm so confused.
It is right.
It looks like we have pink eye.
Yeah.
I found shark teeth on the side corner.
Interesting.
What's the yellow streak for?
Someone made it.
Yeah.
Yeah.
All right, moving on, you guys. Can I have one more nice loud reader? And they never have to be quiet.
Oh, Avery, you know this too.
Priya, why don't you take it away? Everyone, let's listen to Priya tell us the story of the swimming pool.
Swimming pools are sometimes divided into sections that are used for different purposes. A pool may have a section for swimming laps or swimming laps and a section for diving, or a section for experienced swimmers and a section for small children. The lower diagrams are people of pools with swimming and diving sections. The dimensions are in meters.
All right, nice job. Thank you, Priya. Here are 4 pools. So they don't really tell you what these lengths are, right? They're giving you x's. It's an unknown length. What I want you guys to do is, first of all, what do these look like? Do you remember what we did like a long time ago that looks just like this? What do we call them? Algebra tiles, right? Like area models. These are really similar. So this is kind of a review as to how we did those area tiles. What's the length of this side, you guys? 10x. X plus 10. Which one? What do you think? And why are you changing your mind?
Because it's not 10 times X.
Right. This length plus this length. This is 10, x plus 10. So to find the whole area, you have to multiply that by 30. Distributive property. Here's the distributive. All right. This is what I want you guys to do in your table groups. For each pool, it says to write 2 different equations. All right. What are the 2 different forms we know to write equations? What's the first form that we know? Underlined it before. Come on. Avery, do you know? Expanded form and
Excuse me.
factored form. Okay, so I'm gonna go like this, you guys, on this sheet, and write expanded form and factored form. For all 4 of these pools in your table groups, I want you to kind of come up with those equations. So we just came up with one here. It would be x plus 10 times 30. Now you need to find the expanded form by using that distributive property. When you have a couple of these done, you're like, man, I'm kind of bored. Raise your hand, you can come up and put them up on the board so everyone can check them out. But in your groups, I want you to do numbers 1, 2, 3, and 4, and I want to see a factored form and expanded form for each pool. Any questions about that? All right, you guys can start.
Not that you shouldn't do it, but you can't.
This is stuff about them.
No, look, if we divide, yeah, so think to yourself, what times x?
Yeah.
That'd be 3 squared.
It's 5.
Hold on.